Okay, as we have done for prior subjects, confidence intervals, we're going to move on to talking about hypothesis testing for population proportions. Um, Population proportions really are what's probably presented the most in the media anymore. Or X percentage of the population feels this way, responds this way to a survey, something. So we've pretty much covered tests for means and proportions. We're not really getting into population variances in this course. So, but we've covered means a couple ways, and we're talking about proportions now. So in the last two sections, we used a certain algorithm, did things in a certain order. We're continuing that here. State the null and alternative hypothesis, determine which test needs to be used, and state the significance level. Gather the data and sample statistics, um, draw a conclusion, and interpret that. All right, so in general, the best estimate for a population proportion is the sample proportion. So in this section, we'll do hypothesis testing on the sample proportion if the following conditions are met. We're using a simple random sample. Uh, it's a binomial distribution, and the sample size is large enough that the number of samples times the presumed proportion is greater than or equal to 5, and the number of samples times 1 minus the presumed proportion is greater than or equal to 5. Basically, we've got at least 5 values in each side of the proportion. So if we're looking at let's see, 4 out of 5 dentists would be 80%. So we'd have to look at enough dentists that n times 0.8 and n times 0.2 were both greater than 5 to show that. If those are true, then the distribution of sample proportions approximates normal, and we can use the normal distribution and a z-score. As we saw in Chapter 6, the z-score for a proportion is calculated using this formula. We've got our sample proportion minus our population proportion, then divided by the square root of the population proportion times 1 minus the population proportion over the sample size. Should be a little more specific. This is the presumed population proportion. Really what the null value we're testing against. Presumed value from the null hypothesis, as they phrase it. All right, so let's look at a few examples and just work on identifying which test we need. Okay, so scenario 1, we've got a radio station, a local nonprofit radio station, so NPR believes that less than 15% of its listeners favor commercials for other nonprofit organizations. In general, at least 15% are presumed to favor these commercials. And the local radio station thinks that 15% of less than 15% of their listeners appreciate them. So they're going to survey a random sample of 50 of their listeners to test the claim. Okay, so just think about that. What type of statistics are we dealing with, and what's the sample size? What type of test is appropriate? Okay, next one, we've got a college paper that's reporting at least 10% of students turn off their phones during classes. We got one professor who's upset about the number of cell phones that ring during his class, and so he thinks that less than 10% of his students are turning off their cell phones. He's going to take a random sample of 20 students and have them show their phones one day during class. So again, what type of statistics are we dealing with, and what's our sample size look like, and what what statistics are appropriate. Okay, next one. The mean rainfall in southern Texas during September is generally thought of as no more than 3.02 inches. Local meteorologist claims that the rainfall this year has been higher than normal. So he's taken a random sample of 12 locations across the region, assuming the population standard deviation is unknown and the population distribution is approximately normal. Again, look at our sample size, the other things we know, and the type of sample statistics we've got. Which one is appropriate? All right. Okay, so we're given population proportions, 15% of listeners, that's a proportion. So we have to test the conditions for normal distribution. Our sample size is 50, claim is referencing 15%, so p equals 0.15. So we can calculate that sample size times p is 7.5, and sample size times 1 minus p is 42.5. Those are both greater than 5, so we can use the normal distribution for this claim. All right. Again, on this one, we've got population proportion. It's 10% of the students. Plans to survey 20, so in our sample size is 20. We calculate this. Our sample size times proportion is 2, which is less than 5. So the conditions are not met. Normal distribution cannot be used. If he can talk to 50 students instead of 20, he can continue this. Otherwise, he's got to try something different statistically. Okay, last one. It's referring to a population mean, 3.02 inches of rainfall mean instead of a proportion. So we're going to shift to one of the previous sections. Standard deviation is unknown and it's assumed to be normally distributed, so a student's t-distribution is appropriate. Okay. So just like with the other two things we discussed, using p-value, we can do this using p-values. If the p-value is less than the significance level, we reject the null hypothesis. If it's greater than the significance level, we fail to reject the null hypothesis. Okay, so for example, if we've got a school board and they are advertising that at least 65% of voters favor a tax increase to pay for a new school, one of the local politicians believed that less than 65% of his constituents favor this, and he's probably going to campaign against it. So he asked his staff to randomly sample 50 constituents to see if they favor the tax increase. 27% said they'd vote in favor of it. The politician wants to be 95% confident in his conclusion. Does this information support his belief? Okay, so known alternative hypotheses here. We've got, he believes that less than 65% favor it. So proportion, 65% is going to be a proportion. So he believes that the proportion is less than 0.65. The null hypothesis then, the logical opposite, is that the proportion is greater than or equal to 0.65. We can state these mathematically as null hypothesis, p is greater than or equal to 0.65, and the alternative or research hypothesis is that p is less than, sorry, just plain less than 0.65. All right, what distribution do we want to use and what is our level of significance? All right, we're dealing with proportions, so we have to check to see if we meet the conditions to use normal distribution. We've got 50 constituents and a proportion of 0.65, so we can calculate those. Sample size times proportion is much greater than 5. Sample size times 1 minus proportion is greater than 5. So we can use the normal distribution and the z-test. All right, so we've got the confidence level of 95%. So c equals 0.95. Remember, confidence level and significance level add up to 1 or 100%, whichever way you want to look at it. So our significance level is 1 minus the confidence level, or 0.05. So they go out and collect the data, and we get our sample statistics. We show that we've got 27 out of 50 constituents favor the tax increase, so we can calculate the sample proportion as 0.54, which is less than the 65% that was presumed. So he's right on track right now, right? So we put that into our z-score formula, right? Sample proportion minus presumed population proportion, so 0.54 minus 0.65, divided by the presumed population proportion times 1 minus the presumed population proportion over sample size, square root of all that. We get a negative 1.63 for our z-value. Now we are doing this by p-value, not by region. I could find the critical z-value and just compare that, but let's find the p-value associated with negative 1.63. And that is 0.0516. 0.0516 is greater than 0.05, so p-value is greater than alpha. So we should be rejecting the null hypothesis. It is, in things like this, it is important not to round this. It would be very tempting to round this off and say that's approximately 0.05, but that's not what you're supposed to do. So we should be rejecting this null hypothesis, not rounding. It is a politician, though, so all right. Next one. So, according to a report published by the Mathematical Association of America, 1% of bachelor's degrees are awarded in the fields of mathematics and statistics. That is not very many. One recent math graduate believes this is incorrect. She does not know if the actual percentage is more or less. So she does a random sample of 12,317 recent college graduates. Find out what they majored in. She found that there were 148 math or statistics graduates in her sample. Let's go ahead and pull the source up. Does this, at a 0.1 level of significance, does this agree with the published 1%? All right, so let's start with the null and alternative hypotheses. She doesn't know if it's larger or smaller than 1%. She just doesn't believe 1% is right. So research hypothesis is that the proportion is not equal to 1%. The logical opposite is that the proportion is equal to 1%. So we can state those thus. Okay. Which distribution to use and what is the level of significance? All right, let's start with the distribution. We are testing a proportion, so we need to check to see if we've met the conditions. Sample size is 12,317, proportion is 0.01, right? That sample size is rather quite large. 1% of 12,000 is, 12,300 is 123, which is a lot greater than 5. 90% of 12,300 is 12,100, about 12,200, which is a lot greater than 5. I'm being a little imprecise with what I say there because that sample size is large enough that it's fairly obvious that these conditions could be met. Since those are satisfied, we can use the z-statistic. We were told the significance level of 0.1, right? So looking at the sample data, we have 148 out of 12,317, which gives us a sample proportion of 0.012016. We can use to calculate the z-score. There's our formula. Sample proportion minus presumed population proportion over the square root of presumed population proportion times 1 minus presumed population proportion over sample size, as they've done here. And we get a z-score of 2.25. Now we're doing a two-tailed thing, so we need to know what's less than negative 2.25 and what's greater than positive 2.25. As such, we can look up 2.25 in the table and multiply that by 2. We get a 0.0122 for one side. So that's 2.44, and had a helper show up. Okay, so looking at this, we've got our p-value of 0.02, which is less than the 0.1 level of significance. So we can reject the null hypothesis. And yeah, the reality is likely something different than 1%. Her sample size was larger, but our conclusion only refers to the original null and alternative hypotheses, regardless of which direction it said. All we can say based on this test is that, yeah, 1% is likely not quite correct. It would be a slightly different test if we were looking at 1% being small. Okay, we can again do this in the calculator. We don't need to calculate the sample proportion first. It does that for us quite nicely. All that we really need to give it is the presumed value, the sample size, and the number of sample members that have the characteristic we're after. So let's look back at the last example. Right, we've got 1% as our presumed proportion. Recent graduate believes that this percentage is incorrect. Sampled 12,317. 148 were in mathematics or statistics at the 0.1 level of significance. Right, so we've got n equals 12,317 and x equals 148. Right, there's our presumed proportion of 1%. That is p null is 0.01. Okay, we can take this in. The test we're after is prop z test for proportion z test. We can put in our p sub 0, x in, and select that we're looking at a not equal test. Tell it to calculate. We get our sample proportion. There is the p hat. P here is our probability, and there's our associated z value. Yep, there you go. Okay. All right, so we've got a crime watch group that believes the percentage of inmates released from prison who were released because their sentences expired, so they served all of their time, was higher in 2008-2009 for the whole U.S. than it was just for Florida. We've got some 63.9% of prison inmates released in Florida were released because their sentence expired. If we look at a simple random sample of inmates in the U.S. in the same period, they got 64.6%. All right, so let's do this on the calculator. So Again, we'll start with what is our null and alternative hypothesis. We've got the proportion for Florida. Right, we're presuming that it was higher for the U.S. than Florida, so we'll presume that the proportion in the U.S. is higher than what it was in Florida, and the null hypothesis would be that it's less than or equal to what it was in Florida. Right? We can state those as such. What distribution do we want to use, and what's the level of significance? So we're dealing with population proportions, so we need to see if we meet the necessary conditions to use the z-test. So our sample size is 36,463. Null proportion from the null hypothesis is 0.639, so we can calculate this. It's going to be greater than 5 because that is a very large sample size, and that proportion would have to be very small for it to be less than 5. Okay, so we can use the z-statistic. The confidence level was given was 99%. So again, confidence level plus significance level is equal to 100% or 1, whichever way you want to look at it. So significance is 1 minus c, so we get 0.01. So we can gather our data. We've been gathering this as we go along. Looking at the wrong screen here. Sample size is 36,463. Presumed proportion is 0.639. We are given the proportion, not the x value. The calculator needs the x value. It is important to note that we need to give it a whole number so it doesn't give us an error. We were told that the sample had 64.6% released because of expired sentences. So we can multiply that 0.646 by the sample size. We end up with 2,555.098. We'll have to round that to 23,555. So x is 23,555. We presume it is larger. We're greater than p0, so we're running a right-tailed test. So again, we want the prop z test on the calculator. We put in that 0.639 as our null value, that we're after greater than that. 23,555 meet our criteria. 36,463 is our sample size. We get the p-value of 0.0027 and some change, and the proportion as 64.6%. So let's draw a conclusion. 0.0027 is less than 0.01. So we have a p-value less than or equal to alpha, so we can reject the null hypothesis. So the evidence supports the claim that the percentage of inmates was higher for the whole U.S. than it was in Florida.